So I mentioned in the previous video that getting your signs right is hugely important. Otherwise, your robot is always going to be turning the wrong way and nothing good will happen for you. So to demonstrate this, I borrowed a robot from my EGR 345 lab, and it has a line sensor on the front of it. We're going to talk through how to check the signs and then how to follow this line along this board, similar to what we're going to do. So my first move and your first move, anytime you use this line sensor, is going to be to calibrate it. Otherwise, it's going to output garbage. That's no good. I'm going to calibrate inside my setup, and then when that's done, I'm just going to wait at the end of the setup function and wait for the user to input one serial character so that we go on to the actual test. That'll give me time to move the robot into position and get it kind of pointed as straight as I can. Then my code is going to make it drive straight for 200 milliseconds, and then it's going to keep driving straight and turn for 200 milliseconds. And I'm going to be printing data to the serial monitor, and it's going to be a line of data that's either got commas or tabs, depending on how you want to do it, so that I can copy and paste that into a CSV or text file and import that into some program, spreadsheet, whatever that will allow me to plot it, so I can see when I changed and switched on my turn signal, did the robot go the right way or the wrong way? And so let's walk through that. So here is my code. I think I recently programmed this. Some of it's kind of lengthy and not super critical. I've got a calibrate function that I stole out of the example code from Pololu. So I do my setup, I turn on my serial, and then I wait for the user to tell me that they're ready to calibrate, and then we calibrate by rotating the robot back and forth across the line. You might just do that by hand, whatever. And then we wait for a character to start a test. So let's do that. So the robot's programmed. I'm in my setup function. It's asking me if I want to calibrate. I don't remember why in my other course I gave them the choice of not calibrating. You're always going to want to calibrate. And so it's just moving that sensor back and forth across the white and black backgrounds so that it can see what it's doing. The line sensor is down there on the front of the robot over top of the line. So now we're at the end of our setup and we're getting ready to start a test. In the sign check case, there's a P control case that we'll talk about in just a minute, but in the sign check case, it just drives forward until elapsed time is greater than the forward time, and forward time is set to 200, somewhere up at the top. And then we do a turning function where we keep going forward, but also turn with V-turn having a sign of 100 until we get to stop time, and then we stop. So and again, your driving forward and turning would depend on how your robot is built and what kind of stuff you got going on. So I'm going to say start the test. And it drove forward and it kind of curved just a little bit if you're paying super close attention. So initially V-turn was 0, and then it's kind of hard to tell what's going on, right? You can't really plot that in your head. If you can, you're some kind of mathematical genius or something. So I'm going to copy that, and then you would just open some kind of text editor, Notepad, WordPad, I don't care, something. So I'm going to call this data sign check, and I put commas in mine, so I'm going to drop that in there as a CSV, and then that when the millis overflows, it goes back to 0 and makes a mess. So that's time in milliseconds, V-turn, and then position. I'm going to call it line position. And I can't type. And I still can't type. Okay, so with that, if I came over here to my Google Drive and found wherever I had where did I say? I think I know. Oops, not there. 185 template. This is all top secret faculty stuff that you're not allowed to see. So I'm going to open that with Google Sheets. For no particular reason, you could use any program that you wanted that would allow you to graph some stuff. And so part of what I'm getting at is if I then inserted a chart. Right, so because my robot doesn't go perfectly straight when I tell it to drive straight, the line position is initially decreasing. And then I give it this change in the V turn, and then line position starts to increase. So I believe my sign check is working. If I really wanted to get wild and crazy and be 1,000% certain, I could come back over here, and this is how I Arduino. You don't have to pay attention to that. But if I made that negative and saved it and brought it over to the Arduino software, you'd see that it changed it to negative. So that time it kind of veered one way. And now if I reprogram it, whoops. Oh, I unplugged my USB cable, sorry. Programming with a negative V-turn, and I think it veered left at the end of the turn last time. Oh yeah. So, calibrate. Line it up as best I can. And then start my test, and I'm pretty sure it's going to veer right this time. And then if we again copy the data and put that in a text file, so I'm going to call this neg v turn for negative.csv. And save that, and then I gotta redo my labels. There we go again with that. And then come back over to my Google Drive and open with Google Sheets. Now you can see that it goes to 0, which means it actually fell off the edge of the line sensor at some point. Let's see what this looks like. Yeah, so it's a little bit more confusing because we were already going a little bit negative, and then I give it this step change in V-turn, and now it's going more negative, and then something weird happens. But I'm pretty confident that my sign is correct, that a positive V-turn causes position to increase, and a negative V-turn causes position to decrease, at which point I'm ready to then do my P control. Let me find my little flag variable and then go over to the Arduino software. So I'm now at control case equals 2. And so if I go into my loop, that's my proportional control case. So now I'm going to define an error that is 3500 minus my position. I have chosen a floating point KP of 0.1, so that 3500, if I had a maximum error, that would get converted to 350 on my turn. I'm not using a servo, it's a different kind of thing. So that scaling factor may or may not work well for you. But then V-turn is just KP times my error. Then I throw in my saturation function. Just to be clear, in case that was weird in the slides, where's my calibration function at? Right. So I've got a value that I'm taking as an input, and I've got a maximum value, and then I'm trying to find my output. So if my input is greater than my maximum, just return my maximum. If my input is less than negative my maximum, return the negative maximum. Otherwise, just return the output equals the input, and we're done. And so after I do that, I do my robot turn, and I'm ready to go. So let's reprogram the robot with that control case set, and calibrate again, and then see what happens. Okay, the robot is reprogrammed with the control case set to 2, which sets me to proportional control. I will calibrate my line sensor, just like I do every time the Arduino is turned off. Just making sure that the sensor sees in the current lighting conditions, what does a white super reflective background look like, what does a black super absorbent background look like, so on and so forth. And I'm seeing small and large numbers for the two different parts of my calibration, which is exactly what I want. So let's see if it will go ahead and follow this line. You can see that we did that. Seems to have gone well. I could potentially play around with increasing or decreasing my KP values. I might tweak my saturation just a little bit. And if I really want to get better performance, I might start to introduce a derivative term so that I can have an even higher KP value and drive even faster. But it is generally working, and I can build from there.